facing of door alarm. First, create a new project on Proteus, as already explained earlier and again shown here in this video. Get all the components required for the project. Required components are resistor 470, resistor 1K, resistor 10K, SPSD button, SPSD switch, NPN transistor, LCD, LED, and buzzer. Now place the required components at required positions on work area as shown here. Now get required terminals at required positions as shown for connection on the work area. For connections, 2 outputs and 2 inputs are to be used here. The first output is the familiar LED circuit that will be used to indicate when the alarm is armed. The second output is connected via resistor R2 to the base of the transistor. The resistor is necessary to limit the amount of current supplied to the base of the transistor so that there is just enough to switch it on. The collector of the transistor is connected to a buzzer so that it will sound when the output connected to the base of the transistor is set high. The first input is the same small push-button switch as used previously. This will be used to arm and disarm the alarm. The second input is a magnetically operated reed switch. A magnet would be attached to a door and the switch to the door frame, so that the switch will be opened and closed when the door is opened and closed. After the connections are drawn, edit the properties of terminals to assign respective pins to them according to the source code. Head over to Source Code tab for programming. The code to be typed in is available in the description box. The creator has just saved time by copying it from his test project. Anyways, the main while loop of the program waits for GPIO pin 11 IE GPIO 17 to go low when the button is pressed. It then checks to see if the door is closed by checking the status of the reed switch on pin 13 IE GPIO 21. If the door is open, it briefly turns on the buzzer to create a short beep and flash the LED to indicate that the alarm cannot be armed. It then returns to the main while loop, waiting for the button to be pressed again. If the door is closed, it turns the LED on and start a loop that constantly monitors the status of the switches. If the push button is pressed, it ends the monitoring loop, switching off the LED and returning to the main while loop waiting for the alarm to be armed again. If, however, the read switch is triggered by the door being open, it sounds the buzzer and flashes the LED. To avoid causing nuisance with the buzzer, it will stop after 10 seconds, but the LED will remain flashing to show that the alarm was set off until the button is pressed again to reset it. By the way, sorry for the slow speed of simulation. If this video is found to be useful, please do subscribe to this channel to support more of such content in future. Thanks for watching.